Hello friends, in this tutorial we want to simulate this unconfined aquifer by processing Modflow. As we see, the thickness of this unconfined aquifer is 25 and 20 meter saturated and water table 5 meter below the ground surface. We have two wells, one injection well, its flow rate is 75 meter cubic per day, and the production well was 75 meter cubic per day, and the hydraulic conductivity is 3 meter per day. Effective porosity is 0.18. Let's open processing Modflow. First we have to create a new model. I already create a directory Modflow, and the name to well okay. First I have to determine the mesh size. The thickness of the aquifer 25, model top elevation 0. I want to domain 300 times 400 meter. So the length in direction of rows make it 30 row and extend to 300 meter, and number of column 40, and model extend to 400 meter. So the element will be 10 meter times 10 meter. Okay. Now there is a lot of area around the domain. I want to remove this area and make the domain bigger. To appear from option, environment, coordinate system, 0 x naught 0, y naught 300, angle of rotation 0, x1 make it minus 25, and y1 minus 25, x2 425, y2 325. Okay, now it's a better view. Yes, grid layer property. From here we have unconfined. If we can use confined and unconfined transmissibility varies for all cases, but I use unconfined. Okay, and cell status determines the boundary for Modflow. I use Modflow, not transport models. So as we see, the number of all cells 1, it means it's active, and if change it to 0 it will be inactive, and if change it for -1 it will be the hydraulic head constant. So I want to make the hydraulic head at boundary constant. So I select the cell and right click, change the value to -1. Okay, I want to copy this value to all the cells around this domain. From copy icon and by arrow we can do this also. Now the hydraulic head around here will be constant. Okay, top layer, as we see it is 0. Yes, if I have to double click, it shows that the top elevation for all cells is 0. It's okay. And bottom layer, it -25. To verify this, if I double click, it shows same color. It means that all cells have the elevation -25. Okay. From parameters, time, I want to change the time to days, and steady state flow simulation. Okay. Initial prescribed BT hydraulic head. Hydraulic head will be -5. it's 0. I change it to -5 because 5 meter below the ground surface. Reset matrix -5. Okay, hydraulic head emitter. Now all cells have the hydraulic head -5. Yes. And horizontal hydraulic conductivity, as explained it that hydraulic conductivity is 3. So we put 3. Reset matrix is 3 meter per day. 3. Okay. Now 3 for throughout the domain. Yes. Parameters and effective porosity. It is 0. We have to change it to 0.18 from value reset matrix 0.18. Okay. Yes. Now it's finished. Model, Modflow, flow package, and wells. We have to put wells, but before this, we have to determine the mesh in this in the location of the wells. Mesh. If I put here right click and refinement to 3 column and row. Okay. And also make 3 row. Copy. That's the location of the well. It will be, it's 65 meter, and here 20, another one 90, here 95. It's about 50 meter also. And I want to make here a smaller refinement, 4. Okay. And around a little bigger, copy 4. Okay, it's good. Now it's good, and a little bigger here, 3. Copy, and paste here, paste. Okay. Yes. No, I don't want to back up. Copy. Let us supply wells to the domain. Well, I put well here. Right click, injection well, 75 meter cube per day. Okay. Another production well here, -75. Okay. Yes. And I have to run the model, flow package, run, check. Okay. Everything is good. And let us check the hydraulic head or drawdown storage. Let us check hydraulic head. Okay, as we see, it's not a good representation. We can change from option environment, from contour level. I change it to -6 and -4, change it to 0.05 interval. Okay, label format to 2, fix it. Okay, now it's good. It is good. That's the head. And also we can see the drawdown tools to the visualization. Change it to drawdown. Okay, as we see, it's not a good representative drawdown, so I change from environment contour drawdown -1 and 1, change interval to 0.05. Okay, label, fix it to decimal. It's good, and we have opportunity to see the zero drawdown, which make a difference between increase and decrease drawdown. So it is the smallest one. We can change to 0, and we have to change color to a good representation. Okay, now, and that is the region which make a difference between increase and decrease of the profile of water. Okay, and also to draw pass lines, we have to run the PM pass code. It is magnify here. We can add particles. I add 27 particle, diameter around to 402 1. Okay, and I change the particle which is used as backward. Okay, the same, and from option in particle tracking time, I can change the step length. It's 365. I change to 30, and the step it's represent to 1 minute, and change it to 12 steps. Okay, if that is show the forward movement of particles from injection to production well. Now for 1 month, for 1 month, we see that the particle move this much towards the production well. 2 months, 3 months, 4 months, 5 months, 6 months. At 6 months, the particle can travel about 66 to 125. 66 125. It's about 60 meters. Then we can change. First, before that, we can add cross sections. For example, as we see here, 21 row and the column 11. So from option environment cross section, we can change projection row to 21 and column 1. It is yes, but as we see, it's not a good visualization of drawdown. We can change it from option environment cross section exaggeration, change it to 4. Okay, as we see, it's a better representation of a drawdown from the wells. Okay, also in here we can show the contours for head or drawdown. Let us draw down, plot the drawdown level as previous, -1, 1, interval 0.05. Okay. Now change the color to make a difference between the two regions, upward and downward. 0, 1, red color, okay. Label format, okay, it's good. Why? Environment, contour, change it to visible. Okay, as we see. Also, we can represent head, and we can transfer this for drawing by file, save plot as DXF file. You can store it by AutoCAD server here. Just from new, you can make a crop this here and save as, and put to your report if you want. And also we can change the location of this well. In this case, we need to 5 or more these different distances and different time. We can change the location of this well. How we do this? Let us do it. Model, flow package, well, edit. Let us do here, copy to this distance, and also you can delete this one. Now let us measure the distance between the two wells. For first one, 66 to here, it's 124. It's about 60 meter. And how much time the particle need to reach the production well? It's about 6 months. And also here the distance 65, and here is 196. 196 minus 60. Let's calculate the distance. Calculator. 196 minus 65, it's about 131. The distance is 131. Let us calculate the time which particles need to reach to the production well. Okay, yes, we have to run again. Modflow, run. Okay, it's good. And PM pass. Let us remove this section. It's the same as previous. Environment, cross section, visible, okay. And magnify here. Draw particles. 27, 2 meter as previous. Okay, and change backward particles red. Okay, it's the same. And time 30 days, 12 months, 12 steps. Okay, let's start. By 1 month, the movement of particles like this. and this represent 1 year. You see the difference. And for backward, here, now let's calculate. From here we can restart. Let us calculate the time from injection well to production well. 1 year, 2 year, and here by month. 1 month, 2 months, 3 months, 4 months, 5, 6, 7. 2 years and 7 months required two particles from injection well go to production well. That's all. Then we can arrange this time and distance and plot by Excel sheet. Let us do it. Transfer the data for an Excel sheet. For me, at 50 meter requires 9 months, 100 meter requires 32 months, and it's the distance of wells at different location. And this is the breakthrough time which requires. Then you can make a plot which represent the relation between the distance and breakthrough time between the wells. That's all. Have a nice time.